So expected monetary value is one of these things that when I was studying for the PMP exam was just weird as could be to me. So I'm going to say this, don't be like me when I started looking at this stuff. I would have looked at 60% chance of making $100,000 being worth $60,000 EMV, expected monetary value, and I would have thought, I don't get how I get $60,000 in my hand. And that's how I looked at it. I took it literally, like the expected monetary value I should expect to get out of this is 60,000 bucks. That's not how it's intended, so don't do that. Expected monetary value is a way that you can compare things. So if I said you have a 60% chance of making $100,000, you could say this is worth $60,000. And if you compared it to some other project that maybe had an expected monetary value of $54,000, assuming you were using expected monetary value as a selection criteria, then you would choose the $60,000 opportunity because it's worth more. So starting out, basically from a calculation perspective, if I just said to you, you got a 60% chance of making $100,000, what is this worth? The answer would be $60,000. Pretty straightforward. Probability times impact is expected monetary value in this case. Now, there's a way they could trick you a bit or trip you up a bit. So let's look here. What if I said you got a 60% chance of making $100,000 or losing 10,000 bucks? Now you could do all sorts of weird things. You could take 60 times 100 grand and subtract 10. You could take 10 grand and subtract it from 100 and then take that times 60%. Both of those would be wrong. Here's the deal. All possible outcomes have to equal 1.0 or 100%. So if you have a 60% chance of making $100,000, then if the only other outcome is losing or spending $10,000, then you have a 40% chance of that because those are your only two outcomes and they have to equal 100%. So it's realistic that they might leave that 40% off in this case on a test question, just seeing if you really understand the concept. Now what we would do in this case, we look here, technically you're going to add the outcomes. Given this is a negative dollar amount, technically it's subtraction, but the way the function works, you add the outcomes. So you have a 60% chance of making $100,000 or a 40% chance of losing $10,000. So 60,000 or negative 4,000, you add them together, it's $56,000. So think about it this way. You got a 60% chance of making 100 grand, and it's going to cost you 10 grand to try to do it. So if you don't get it, you're still going to spend 10 grand. So you could say this is worth $56,000 when comparing it to some other possible thing that you could do with your time and money. Now, that said, let's talk about a decision tree. So before we go to that graphic, basically, we could take this, and like I said earlier, maybe a $54,000 project, and if this is your criteria, you would choose what has the biggest dollar amount as worth. So a decision tree is just a branch, two branches, which route do I go based on what has the higher dollar amount. Now, the decision tree we're going to look at has a little bit of a funky step in it because it's got revenue or probability and impact, but it also has expense. So we're going to show you how to factor that in. So far this is expected monetary value. Now we're going to the decision tree piece of things. So to clarify, this A through F that you see at the top of this graphic and what looks like a little afterburner after the graphics, these little lines, that's a Crosswind way of doing things. So you should not see that anywhere else unless they got it from me. So just be aware on the real test, if you get something like this, you're going to have to put the lines there to kind of keep it straight. So let's look at what's going on here. Buy or retool is the question. Now, all of these numbers would have to be provided from an exam perspective. About the only way they could really leave something out would be like where I have 65% and 35%. If they gave you a 65%, I would expect and hope that you would realize 35% as the other outcome, because if you only have two choices, they have to equal 100%. Now, the deal is this, these numbers would have to be provided. In reality, somebody's going to come up with these. Could be an individual, could be a group of people. But the bottom line on this, if I buy a new company to create a product, according to this example, it's going to cost me $400,000. Now, we feel there's a 65% chance that we can make $900,000, which would meet or exceed sales projections. We also feel that if we don't do that, there's a 35% chance we would make about $400,000. Now, on the bottom side, we could spend $350,000 to retool the current company to create a product, and we feel there's a 65% chance we can make $500,000 or a 35% chance we can make $400,000. Now, I'm not going to get into why does retooling all of a sudden have me make a lot less money. That's not it. That's not relevant. It's the numbers you're given. Now, the thing is, if you ignore the $400,000 buy a new company box and $350,000 retool current company box, this looks kind of like what we just looked at on the previous part of the video here. Just probability times impact, add the outcome. So if that $400,000 box wasn't there with buy a new company, I take 65% of 900,000, 35% of 400,000, multiply them respectively, add the outcome, that's what it's worth. So that's pretty straightforward. Unfortunately, we got to deal with that $400,000 buy a new company box and $350,000 retool box. So here's the deal. The column C, if you will, which is 900,000, 400,000, 500,000, 400,000. Think of those as revenue. And think of column A as expense. So here's how it's going to work. If you look at column D, that is C minus A. So you're going to basically take the 900,000, back out your 400,000. You're going to take the 400,000 right below it, back out your 400,000. Then those numbers respectively are going to get multiplied by the respective probability. So let's go ahead and just forward a moment here. So you see my 900,000 becomes 500,000. My 400,000 gets zeroed out. So 0 of 0.35 is 0. So 500,000 at the top part of that, multiplied by 0.65 is 325,000. So I would say that potentially it is worth $325,000 to buy a new company to create a product. But on the bottom side, I would only say it is worth $115,000 to retool. Now, you might be going, who would use this? Okay, let's not get into that. If this is your selection criteria, what you would do is you would say it makes more sense to buy a new company instead of retooling the current company. But who would use this? Students of mine that have used it, they've worked for defense contractors, oil companies. I once had a student in class, he said their law department, or where the lawyers worked in the legal department. There you go. They used it because they were being sued, and they looked at what they thought their chances were of winning or losing, depending upon how you wanted to look at it, versus what they were being sued for versus what they thought they could settle for, and they used that as an approach to determine, do we try to settle or do we go to trial? But you can walk through the numbers here step by step and see how it works. But the key is, just like on the bottom, the $350,000 gets backed out of your $500,000 for $150,000. Your $350,000 gets backed out of your $400,000 for $50,000. Then those essentially net sales get multiplied by your respective probabilities. And then you add the outcomes, you come up with $115,000. So that's how you take the expected monetary value piece and then factor it into the decision tree calculation.